Hey everyone, Assalamu alaikum. I hope you all are doing great. This is Taha Sajid. Welcome to my YouTube channel. Uh, in this video, I'll be discussing, actually taking you through the 5G hands-on experience. If you are on my channel, if you have noticed, I have done a couple of videos in the past as well. One is the 5G registration process, and the other one is 5G session management. I have got quite a bit of likes and comments. Your feedback is very important, so thank you for that. So I thought maybe in this video I should cover 5G from the hands-on perspective, that what are the different tools we can use, and also would give you a view of the radio access network as well, that what are the different concepts, important concepts with respect to 5G that we should know about. So let us start. I'll share my screen. Okay. So yeah, so the objective for me in this video to take you through Scapy, Wireshark tracing, Swagger, will show you Cartoradio, and we'll cover important concepts like beamforming, massive MIMO. We'll go through standards and specifications as well to what is ITU, what is the role of 3GPP, and ETSI. I'll take you briefly touch upon the public and the private 5G networks and what are the different tools and technologies that we use in both of these deployment scenarios. Okay, so let us start with the different modules. So before I start, actually, I want to thank LabLabby, for giving me the opportunity to use their tool, to use their platform, to take you through different labs, as well as to show you the concepts in a much better detailed view. Okay, so before, okay, let us go to and start with our first tool, which is Scapy. So if I can come in here and go, so Scapy is basically a tool which we use to generate packets into different layers, understand the response behavior, and it also helps us to analyze the protocols better. That what are their functionalities, how the packets are structured, and it helps you in troubleshooting scenarios as well. And if you are from the security background, that you can also use Scapy to check if there are any like open ports, and to check that how the network is set up. Okay, so what we'll do, we'll just go directly to their labs here. So this is, if I can show you from the starting, I can come in here in this lab. They have set up different challenges. So I'll start with Scapy here. So just to show you that if I can want to just generate a packet. Okay, I can just come in here and just see it's not saying. Okay, so because we have not specified any like attribute, so if I can just click this again. Okay, and we'll take you step by step here. Okay, so if you want to create a packet, you can just copy in here and just create a packet. Okay, but it will not send anything. Okay, but if you want to send it, what you can do, you can use this sr packet command in order to send the packet to. Okay, and if you want to further analyze this, you can maybe use other commands, which is, for example, if I go in here and would needs to send when we want to send the packet, and if you want to know further details of it, you can use sr1 packet command to do it. So let us do this and see that how the packet looks like. Yeah. Okay, so here you can see different like the payload information of different segments of a packet, like what are the source address, what is the destination address. So this is very important concept if you want to understand how the packet is structured. Okay, so this is about a brief intro about Scapy. Obviously, you can do a lot of other things as well. But for the sake of time, I'll not be touching this in more detail. But this is a way that like you can use in your operational and designing activities. Okay. Coming again, going to our next topic, I want to cover the next topic is I want to show you how the messages flows between different network functions and how you can capture them using Wireshark. So in this challenge, what I'll do is I'll first launch NRF. Then we will start the Wireshark trace, and then we will launch AMF. So what I need to show you that how the AMF is sending the messages to NRF and how you can capture them in the Wireshark trace. So let us start, and I'll start this lab like this challenge by starting NRF here. Okay, so when you click this, it is showing you that it is getting started. And as it getting started, I can maybe open up the capture EMF to NRF registration. Let me open this up and I'll use this. Okay, press enter to exit. Now what we will do is we will also start EMF here. So I'm starting EMF now, you can see. So, and meanwhile, what I can do is I can just go to here, network functions here. This is where the lab is. So you can, as you will go through different modules, you will see different challenges, which is very good in getting a hands-on exposure to all this. Okay, so we are using this challenge basically. This is what we have started the trace of capture EMF registration to NRF. What we need to do is we need to get on to the Wireshark platform. Okay, so yeah, so just capture cross this one, and then we will do what we can do here is we can come in here and just see if I am able to capture the trace. Yes, so the trace is captured. Now what I'll do is I have to open Wireshark here. Okay, so yeah, this is, I can come in here, open. This is my file, which I can see in here, which is generated, the PCAP file. I'll just come in here and open this PCAP file. So if I want to filter, basically that just directly go to, I have to select this HTTP2 filter. So I'll come in here and just select this HTTP2 filter. You'll see the traces coming in here, and then you can try to understand the messages. So if AMF has to register the NRF, the AMF has to send its NF profile, and NRF has to send some response and whether the registration is accepted or not. So this is where we can see the messages. So let us take this thing step by step. So the first message is what we can see. First, we have to edit the preferences here, so that we can get the HTTP, the right protocols, the right preferences. Okay, so I come in here, I go to edit. I think it's maybe it's selected by default, but just to double sure. HTTP2. Okay. So what is the first message we want to see? The first message we want to see is this magic 132, which is just like a starter message. But the important thing is here you'll see that from the EMF one, which is 127.0.0.1, it is sending the request to the NRF, which is .10. Okay, so this message is indicating this IP and this port message. So we'll come in here, you'll see this message is actually, it is sending the delete message, but let us try to find this message. Okay, so this is the message where the AMF is sending the request to the NRF to register the profile. Okay, so if I can come and if I'll be able to see the response as well. 10 to 1. Let us see if the NRF has accepted the request. Okay, so 10 to 1 headers created. Okay, so this is what you can see in here in this message, that the header is created. Okay, and if I want to get the response, so this is the message. For example, the NRF is saying, like, sending from .10 to .1, that hey, the request what you have sent to me, I have accepted the request. Okay, so this is a good way of visualizing your call flow. Okay, then next what we want to do is to launch the other network functions as well, and then we will start the GnodeB, and also we'll start our UE, and then we will like check the registration like messages call flow. Okay, so let us go and open the other network functions as well. So we'll start with AUSF. AUSF is the authentication function, which is newly introduced in for like 5G. It was not there in 4G. So this is something which is new in 5G. Then we will start with UDR. UDR is the data repository of 5G, where you can store the subscriber information. UDM is another part of the subscriber data management platform. It functions same as HSS in 4G. So we'll start with UDM. We'll start UDM. We'll start SMF. SMF is the session management function, which helps to manage the session of the UE. We'll start PCF. PCF is a policy control function. It helps defining the policies, the quality of service parameters, that what policies goes into different UE. We'll start NSSF, which is for the network slicing. We'll also start UPF here. Okay, UPF is a user plane function. It's the data. It helps in setting up the peers towards the internet, as well as towards the N3 interface towards CNOTP. Okay, so now we have all the network functions have started. What we can do is we can start the GnodeB now. Okay, we'll start the GnodeB. I hope that it's as simple to launch any network functions, but you have to design the site, you have to commission it, it has to go through a lot of process before you can actually launch GnodeB. So this is like very easy right now. Okay, so as GnodeB starting up, what we can do is we can start this trace message as well to capture the 5G registration process, because I don't want to miss any trace, so it's better to start this trace right now. And then what we will do is, as the GnodeB is starting up, I'll see it usually takes like 30 to 40 seconds before the GnodeB can be launched. So what we can do is we can come in here and check if the GnodeB has. First, we will check this messages. Hold on a minute. Successfully, very good. This is also successfully, very good. So this is here you can see that the GnodeB is starting up. The SCTV connection is establishing. So it is good that it's now launching. Okay. Now what we can do is we can also start our UE, which is having a 5G SIM. Okay. So as I have launched the UE, here you can see the UE is starting. It all starts with the registration process, where the RRC status is connected. The CM is also connected. You can see different cipherings taking place. Then the security mode complete, mode command being complete in order to establish the security context between the UE and the GnodeB. You will see also the UA access attempt is allowed for identity, the PDU session establishment accept receive, and the connection setup or the PDU is successful. So this is good. So what we can do is, what we have started the registration trace of 5G of Wireshark. So we'll see if this is captured or not in the Wireshark. Okay, so pcaps. Okay, so now what we can do is we can go and see our Wireshark trace. Hopefully it is we can able to see the messages and we will be able to see what is our SUPI, what is our DNN, what is the AMF ID, so we can see all those informations in our trace. So if I can come in here, I can just open this trace, which is the registration PCAP. Okay, I have to do now. I have to do some filtration in order to find my SUPI. So what I can do is I can just quickly come in here and maybe I can open this registration module. It has some good filters which I can use. So I can come here. Maybe I need to. No, okay, so this is the filter I need to use here. So I want to see basically the PFCP message, the HTTP headers. So this is, I'll just use a shortcut here to filter it. Okay. So I come in here and just select the PFCP message. Then I have to search basically the SUPI information. So I'll come in here, select SUPI. Okay. I have to use string, which is good. So this is my SUPI. Hey, very good. This message is coming with SUPI. And if I have to find AMF ID, you can find in here that what my AMF is. Basically, this is the message. The AMF is .1, which is this, and this 10 is the NRF. This is where I can see my AMF. If I want to search the DNN, so DNN, you have to go through and check my check the DNN here. So you will see the DNN as well, which is this message. So see, this is where you can see different parts of the message in the white. So it helps you really in order to, if you are troubleshooting or if you're understanding different call flows, making sure that the network functions are properly launched, they're not having any errors. So this is how you can come in here and check all these messages. Okay, so now we have covered Wireshark traces, the registration process. We have launched different network functions. Now let us go to and check the API monitoring and designing tool, which is called Swagger. Also, the example is very simple. Here, what we can do, we can open the Swagger, the link here, which is provided by LabLabby, and just copy the YAML file from one of our labs here. So if I can come in here, you'll see the YAML file. I think it's part of the challenge number 8. So you can just copy this file. Okay, so it is important to understand because APIs are mostly used in a lot of use cases. We have provisioning use case. We have if you want to capture or update any information of our V2X service, which is like a vehicle service, like for the smart cars to update the speed, all that information you can query and you can update using the APIs. So let us go and copy this module. Okay, so let me clear this text, copy this YAML file. So as I'm copying this file, you'll see here, I can see the representation of this YAML file in here. Okay, so this is good. Then if I want to just try it out, connectivity management, for example, if I do a post request, terminate a session or what, I can see the messages flowing in here, whether the session is terminated and session not found. So you will see the codes coming in as part of the response of the APIs. Okay, one of the use cases which they have explained in here, this example, which is the 5G APIs ecosystem. So it has you have APIs in the 5G core network, you have APIs in the radio access network, you have location-based APIs. So you have a lot of APIs which you are having, and you can use the Swagger tool in order to communicate, to create the APIs, and then in order to communicate with those use cases. So this is very good examples here. They have also given some use cases as well. If you want to, let's say, use a V2X service, this is how you can use it. You can use, maybe there's a scenario where a developer has developed a mobile app that communicates via API with a V2X service. So the communication of V2X through mobile app, then the mobile app has to send an API request to the V2X service. So so this is an example. If you want to, let's say, update your car speed or to get the service, to get the speed or get the location of the car, you can use that mobile app in order to send the request across that V2X service. So this is just an example that if the V2X car service has the car speed, the red light is on, the car's current position. This is if this is all it is containing. What you can do, you can use a developer can develop a mobile app, and can query, get the latest updates about the traffic details. That hey, what the traffic is in this particular area. So it already capturing all that information. So you can just use your app to query all that information. So this is a good use case and a good research project as well if you want to go to this path. Okay. So now moving on to the other side of the domain, which is the radio access network. So I just want to take you use case where we use Cartoradio. So Cartoradio is a popular tool in France. It's helping regulating the deployment of wireless communication. You can basically see like where are the different radio towers. If you want to check the footprint of any operator, like whether it has a 5G service, where they have placed their antennas, what is the signal strength, the coverage areas. It will help you in order to understand all this thing. So let us start with taking an example. I'll go to this lab here. Just 1 minute, let me close these windows. Okay, so what we'll do is we'll go to one of the challenges here. I'll be opening up this. Okay, this is the how Cartoradio looks like. So this is an easy to use tool where you can just put the address here, whatever you want to search. So for example, if I want to search, let us see, if I want to use the location of Paris Shore Airport, what we can do in here, I can come in here. Oh, where is it? Yeah, to come in here, I can just copy paste the address here. It will take me to that spot. Okay, and I can maybe use this to further see all my things here. So if I come in here, you'll see I can able to see what are the different mobile operators who are working in this area. What technology it is. So if I just take out 4G, 3G, 2G, I'll see only 5G in here. Okay, you'll see different services here. So if I want to see the footprints, I want to see the radio tower is all coming in here. Okay, where are the private mobile networks? Okay, so this is done shown by this symbol, blue diamond symbol. Okay, then so this is a powerful tool in trying to see the footprint basically, and how I need to set up the antennas, where it makes sense for me to use more antennas. So this is the important tool which I can which you can use. So with this tool, I want to explain you two important concepts. One is the concept of massive MIMO. So massive MIMO, if is you can use, you are using multiple inputs and outputs, like increasing the transmitters and the receivers, and it has been mostly used where you are using, where there's a massive crowd, like like the stadiums and the concerts, where they can use this technology. Uh, and to just show you an example of this whole massive MIMO concept. So in theory, what you know is you can, let me go through and first show you this thing. Okay, so here you can see these are the different areas where they have set up their antennas. So there's a normal behavior for a provider to use many antennas that point in different directions. So if you use 2x2, 4x4, it depends on how you want to set up or design your network. But with massive MIMO, what you can get faster speed, better signal quality, more devices can be connected. So it is a good like a great way of enhancing the user experience basically. So this is a good example where they, in this FIFA World Cup, in the stadium, where the FIFA World Cup took place in 1998 when I was a small kid. You can see that they have placed the antennas here, and the one antennas is pointing to different directions. Okay, so this is where they have used this massive MIMO. Okay, and you can easily visualize this by opening up this, and they have explained this concept in more details in their modules, which is a good way in order to understand all this. Okay, and you can while going through this theory, you can easily go through the labs here, and you can easily search and open up Cartoradio, and you can visualize where this all is here. Okay, so this is very good concept, very good way of visualizing all this. Okay, the other concept I want to show you is the concept of beamforming, which we use in we use the term in 5G, which is pointing, like, think about if you have like lots of flashlights, and you have to zoom in one particular location to have more like clear view. So you can like visualize this like this thing in your mind, that if there's like only one bulb versus 10 bulbs pointing to one direction. So when I was a teenager, and in my early days, I used to play, like, we used to play cricket, like a night matches. Within the night, we used to play cricket, and we used to have like different bulbs, hanging on our roads. So what we have, like, but those bulbs are so many, like they're scattered all over the place. So there's a strong chance when you are, making a good shot, you can hit one of the bulbs, and you can end up, crashing that bulb up, like fusing that bulb up. But what you can do, instead of having 10 or 12 bulbs, you can use a hanger. You can use an LED where you will be getting more out of your or money, and it has just one or two LEDs you can use, instead of 10, 12 bulbs. So this is the small analogy of what the beamforming is. The beamforming is a concept where you can, instead of using multiple antennas, you can focus your view into different directions specifically, and which helps you in getting stronger signals, reduce interference, and better coverage. Okay, and to explain this concept, I can maybe take you to this lab where they have show you how you can visualize the beamforming concept. So here, this is the lab. This is the challenge number 6, where you can come in here and see yourself that this is the challenge number 6 here. Okay, so here you can understand the concept of beamforming, which is basically, if you are using one by one antennas array with 60 sectors, you can get this picture where you can see the picture is not like the signal to noise ratio is not optimum. Okay, whereas if you can set up more antennas, you will see this is getting narrower. So this is where you can see the result of having more antennas. So if I can come in here and show you the 10 by 10 antennas array, you can get a lot of flexibility to precisely control and direction and quality of the signal. Okay, it's like having a team of sound engineers using a vast array of microphones to capture and fine tune audio. This is one way of understanding this. Okay, so this is a good way of understanding how the beamforming can help in trying to nail down the signals for you in order to achieve better results. It can help you precise signal direction, interference reduction, helping you like reducing or improving your SNR. So this is all the benefits that you can get. So that's it from my side. Sorry, before I go, I want to cover also two topics. Just I'll give you a brief theory of it. One is the standards and the specifications part of 5G. So if you notice, there is, you need to understand the ITU, which is the International Telecommunication Union, which works with different, it has different initiatives, it has different working groups. Each working group has repertoires, which are the lead of that group, and which collaborates and interact with different companies in order to set up that work proposals. Okay, and then there is 3GPP, which is an umbrella term of for several standards organizations that develop protocols for mobile communication. It operates on different releases, so with every release they're coming up with their new standards. Some changes are also taking place. Then they also have different working groups. They have technical specification groups, which like SA2, SA3, SA4, different SA groups are there. Then we also have, you know, ETSI group, which is the European Telecommunication Standards Institute, which is also a group which works for the standards, and they collaborate with each other. So the ITU like collaborates with 3GPP in trying to set up the standards, and 3GPP partners with the HC and the vendors and the mobile operators to get through and to show us that, and to guide us at what process and the requirements are there for different releases. Then the other part I just want to like touch upon is the different patterns of the 5G network. So you can have it deployed it as public, which is for the telecommunication, for the public, basically for the providers, for the consumers. You can, with this, you can use dynamic spectrum sharing. This is something which is coming in new, like it is coming. It has been there in 4G as well, but it has been like utilized more with 5G. It helps you operators to actually share the spectrum between different 4G and the 5G networks. We are also seeing 5G networks to be used as a private network as well. So if any organization or entity wants to use 5G, we can, with this cloud native functionality which 5G offers, and network slicing feature, you can easily configure a separate 5G network for an organization. Okay, and it can help, which can help them in order to give better data rates to their customers, to help in security part of it. So this is one of the use cases which we like where we use 5G. Okay, and with this Cartoradio tool, you can easily go and check that what are the areas where the 5G private networks are. So this is also good way in trying to visualize all these concepts. So yeah, this is it. I hope that you have enjoyed this video. Let me go back here and just stop sharing my screen. Okay, so I hope that you have liked this video. I try to show you, gives you some hands-on experience on different tools. Again, a big shout out to LabLabby for the wonderful course content that they have created, and also the engaging and interactive labs that they have provided on their platform. It will really help the community, and I hope that I have provided you good insights of all this of this platform. I really liked it, and wish you great luck in your careers. And until the next video, I'm signing off. Thank you very much.